Hello and welcome back to Mr. Powers Teaches Algebra. Algebra 2, Algebra 1, I don't know. Algebra is algebra. So, we're going to talk about graphing polynomials. And in this first video, I'm thinking we'll just focus on the shape, the look, and the roots. We should already know how to find roots, but just maybe a quick review on roots and zeros. What they are is where we cross our x-axis on our graph. So, without further ado, we've got a little bit of stuff on the screen here. Feel free to take a look at that. And let's investigate some polynomials. I put in here a general equation for a polynomial of degree 5. ax to the 5th plus bx to the 4th plus cx cubed and so on. And where I could mess with the coefficients just to get different looks of what these graphs look like. So let's see if we can get a good feel for these. And you know what, too? Let's get that a little bit bigger here also. Kind of like that better. All right. And so right now, actually, it says ax to the 5th, but it's 0. My a is 0, as you can see. So, hold on a second. All right, so anyway, so we actually have this time right here is a quartic. And talking about turning points on the other side there, I guess we'll mention what those are right now. Since I have a quartic, my highest, this degree polynomial is actually 4. The way I look at it is we start going up one way as a 1, 2, 3, 4. There's my quartic. But another way you could think about it is if it's a quartic, it's going to have, if it's degree 4, it's going to have at most 3 turning points. Or maybe exactly 3 turning points. No. Depends. But here we go, at most. So, 1 turning point, we'll call these right here turning points. We're going increasing and then we're decreasing. Then there's a second turning point. Third turning point. Okay, so that's something to notice, and let's play with this a little bit more. Let's make it a, and then here are our zeros, of course, our roots, right there, and we have 4 roots, which would make sense. 4 roots, and it's a 4th degree polynomial. Let's go ahead and make a something. Let's go a is 1. Now, that's funny. It looks like only 2 turning points. Weird. Let's make it negative. All right. Now, there's probably something in there maybe that's hard to see. But anyway, the point of all this was to play around with this, see what we can get. What kind of graphs do we end up with? And what do we notice about these? Oh, there we go. Okay, that's a little bit better. We got to try to get all these turning points. So anyway, the point of it is, you see, there's 1, 2, 3, 4 turning points on this one, and this does have a coefficient on our x to the 5th. So this is a 5th degree polynomial. And so we're playing around with all these, and we're seeing that it's always smooth. There's no jaggedy edges, right? When it switches direction, it does it slowly, right? There's not a set point. Sometimes it goes pretty quick, but it's always nice and smooth. There are no holes in the graphs. So we'd say it's continuous and smooth. And all of these act like this. No matter what we do with A, B, and C, I can get rid of C there. So no x cubed now, and we just have an x 5th, x to the 4th, and x squared. And play around with this all we want. And just see what happens. There we go. Of course, if we make all these 0, now I just have a quadratic. Okay, but anyway, enough of that. There's our quartic again. All right. So, now that we got to look at those, let's see what else I wanted to go over with you guys. Okay, so we got an idea. We know what these look like, right? We talked about the turning points. Let's see here. We talked about the roots. So we do have roots here. Here in this one example, we got 2 roots, 2 places, and I actually have this showing me where they are also. It wants to give me 5. Why does it do that? Well, because I kind of told it to. But anyway, there are 2 roots, and there they are. Knows where they are. And those are the same places my zeros are. Those are my x-intercepts. This is where, because x-intercepts is where y equals 0, setting our function equal to 0, all the same thing. Okay, so we have that. All right, we got all those relationships. Let's see here. So yes, here's all those relationships again. Now this brings us to something else. I think this was the last thing I wanted to talk about. So if x equals r is a 0 of a polynomial p of x with multiplicity k, talking about multiplicity again, if k is odd, the x-intercept corresponding to x equal r will cross the x-axis. If k is even, then the x-intercept corresponding to x equal r will only touch the x-axis and not cross it. Now, why is that? Let's take a look at some more polynomials in a different light. So I wrote some out here, but they're factored. And so we have zeros or roots with different multiplicity. Right here, we have -2 in g of x. -2 is a root and -4 is a root, but -2 has multiplicity 2, and the root at -4 has multiplicity 3. And so you can see that what happens here, and we can zoom in on this, is that multiplicity 2 at -2 does give us a root. It does give us an x-intercept, but it doesn't cross. It just touches and then comes back. Now, why does it do that? After you play around with these a little bit, you kind of realize that near this root, it behaves much like the power on the root, the multiplicity. So if it's squared, this is going to look like a parabola, just like x plus 2 squared. If you had just x plus 2 squared, for instance, here we go, right? It is a parabola right there, right? This one is a little bit more narrow, more scrunched in because of the x plus 4 cubed as well, but you do have that same kind of shape there. And if you had x plus 4 cubed, you're going to have a cubic at x plus 4 at, well, -4, 0. See, so let's see here. And so you get that shape right around here. It kind of takes over when you're really close to that value, the value in here. So -4, what makes this 0? This is going to control the shape right around that area. And that's the way I remember these kinds of things. So let's take a look at some other ones, okay? Here we have roots at 2 and 5. X equals 2 and x equals 5. We have roots. So 2, now let's go ahead and zoom out a little bit. Bring this in. There we go. But they're both even, so they're both like parabolas right around there. And that's the way I remember it. Or you can just remember the rule, If the multiplicity is even, it's just going to touch it, not going to go through. Here we have two evens and an odd. So touches at 2 and 4, but at 6 goes through it. And it's a linear one, and you can look, if you zoomed in right here, it looks pretty straight, like it's a linear, like it's a line, because that factor is linear. But when you had this one, it was cubic, so it goes through, but it looks more like a cubic. Okay, so that's how you can remember those rules really, really easily. Okay, and I think that's all I needed to go over with you guys, yes, in this video. It takes us to about 10 minutes. So a few things we'd want to remember here. And that is really the shape of these polynomials is always smooth, no jaggedy edges. Yep, they're always smooth, no jaggedy edges, no gaps, no holes, none of that weird stuff. And the way roots with multiplicity work. If there's odd multiplicity, like here at -4, it goes through the x-axis. If it's even, it's just going to touch it. All right. And that'll do it. So until next time, enjoy doing math.